me. As been already mentioned, my name is Zahedi. I work as a research assistant at the chair of Professor Petzold in TU Munich. This paper is about, as part of a research project financed from DFG, we tried to develop a adaptive minimized communication protocol based on BIM, which I'm going to explain. The task of designing a building is a complex task which involves so many different actors and so many different domain experts. The problem with early design stages is that there are always incomplete information, and at the same time, the sheer load of design decisions concerning so many design parameters. What could always legitimize this process is to ask for simulations analysis in support of these design decisions. Yet again, the problem is that there's always incomplete information and missing details. Our solution in this research group was to adaptively detail and suggest information which is missing to the architect as the designer, while providing him with the results or corresponding results of the simulation analysis so that he can maybe decide better in advance in these important early design stages. For this, we need a communication between architect and so many domain experts in order for him to transfer these details and at the same time these simulation results. But at the same time, what we were aiming for was that to make these communications somehow minimized as much as we can, and at the same time making them computer readable so that at the end, hopefully we can use all these communication instances for different purposes. So once we can gather all these things, at the same time, we can also try to understand and maybe find hidden aspects during this design process. BCF, or the Building Collaboration Format, is the most famous issue management communication protocol, being already approved as a standard by Building Smart. Since 2010, it's been developed, and in the second version, actually, BCF also supports computer-readable or machine-readable communications using so-called BIM snippets. This shows an example of a BIM snippet, which is practically a partial IFC file. As you can see, this partial IFC file tries to set up a value for fire rating, which would be W90, and referring to a certain IFC product, which the global ID is written at the top. So to set up a property, this is like an example how a partial IFC file have to kind of overwrite that IFC file. So as if you have to contain, pack, and transfer all this data every time. Our solution was based, just like BCF or any other issue management system, on a ticketing system. So each request for analysis would be treated as a ticket and would have an ID, who's created it, what's its due date, its current status, and who would be responsible for it. The second half of our communication protocol for each of these tickets will concern a function method, like a signature method, who will inhale these packages being sent back as report for missing things, also options, which are suggestions to fulfill those missing details, and can be chosen or rejected by the architect. At the end, every partial mode or everything would rest on a common data environment rather to be inhaled in these communication instances, and architect would be the sole design decision maker, accepting or rejecting all these suggestions. This shows the feedback method with all its arguments, which based on the use cases, some of them may exist, some may not. The first argument is the action type, who actually defines what kind of a purpose this feedback method at this instance will be serving. Is it reporting a missing detail? Is it reporting a missing object property as an object or object property? Is the engineer suggest to create a new object or delete an object or object property to be updated? Is this change or suggestion packed or bundled in a set of suggestions so that can't be handpicked? It will defeat the purpose, so they will all share the same option group ID, which building component is it referring to inside the BIM model. The heart of this protocol is this so-called ALODX template, which I'm going to explain in the next slide. And then using the template, we refer to an object ID inside the template, and if the use case necessitates, a property ID as well. If we're suggesting a new property value, then the value would be present, and in an upgrade, maybe also a rating for this value in comparison to the other options. This shows the template. So what we have in our protocol is this adaptive template, which is kind of a requirement being defined by different domain experts for different design stages. They will define what kind of building components necessitates to be present for this simulation or analysis to be run, which kind of property should be present there so that they can perform the simulations. And for each design stage, for each simulation, this template could vary and could change. As you can see, properties could be shared with these different building components and in different templates. We designed a communication history server as well in a relational server, trying to record all these instances of communication. To make this design as minimized as possible, we tried to have like a product catalog mentioning all the components and a property catalog once, then assigning them with a table together, and then assigning these rules for different templates, while the rest of the relational server deals with this ticketing system aspect of the communication with people, projects, and assignment tables between them. Request for analysis would be triggered as a ticket, and then the feedback function would be sent back to them. This shows a simplified generic example how this will be executed. Imagine the architect asks for embedded energy at the early design stage. By requesting, a ticket will be triggered. This shows a screenshot of a Revit plugin which we developed in order to showcase the proof of concept of our protocol. As you can see here, the role could be seen here. Now it's the architect, so he requests a new analysis. He can set what type of analysis. We also had in mind to advance it into the scope of analysis, so it would be also possible not to send the whole thing or the whole model for analysis, rather than only parts of it. Who would be responsible for it and the time? On the way back, after examining the content of the model, the engineer will suggest that there are certain things which are missing from my analysis. Window-to-wall ratio, again in the simplified example, the outer wall material as the material group, and the thickness of the wall. The architect, how the feedback function actually looks like is, for this example, it's now reporting a missing object property. In the beginning, then the option group would be null because it's not being used in this use case. It refers to the outer wall as the whole building. The UID of that component refers to this template which we already mentioned, and it's actually related to one of our part projects in this research group which deals with embedded energy, and then refers to outer wall. The first time, the window-to-wall ratio as the property ID, the second time, the material group, and then the thickness. This shows how this report will look like in this Revit plugin. Different ways to show this report is also part of our research, different visualizations of the same report, which we're still having it in progress to improve it. And later on, the architect could decide on a window-to-wall ratio, which he approximately knows what he's going to have, or maybe a thickness at the same time. But he can ask for suggestions or options for outer wall material based on the results of the simulation from the energy expert. As you can see here, then the engineer may add suggestions or options to be given to the architect. These suggestions could be from different data types, but here it will just concern the material. of the outer walls, he can suggest 4 different options, being concrete, wood, bricks, and steel, and at the same time giving the results of the embedded energy based on these options so that the architect can have a better understanding of the consequences of the decisions he's going to make. The feedback function this time looks like now he's as the action type, updating an object property. Each time he suggests a material group, it would be one option group ID, and then again the same ID for the building component, which refers to the same template, outer wall, and the property ID would be material group. If it's the concrete, then the value of the concrete would be present as the value. This shows again how the plugin will look like. You can also ask Revit for its catalog of material groups. He can also filter them. He can add multiple suggestions if that tick has been mentioned there. So instead of 1, he can add multiple suggestions to the architect. And again, in this generic example, we can say that the architect trying to go for the better results, which was the bricks, but then asking another domain expert about the structural analysis, he may find out that, the wood, I'm sorry. It's not load-bearing, so it might not be a good solution, further stages for another aspect of the design, so he chooses himself for bricks. As I mentioned again, the architect would be the sole decision maker in this design process, so every and each of these options could be either rejected or accepted by the architect, and none of them could be, in our eyes, seen as interference in design tasks for the architect. At the end, he's free to choose them. Even he's free to consider different design aspects. He would also say that in despite of the better results of any sort of a simulation, I will decide myself for something else because I have something non-tangible, like subjective rather than objective in mind, and this will serve my purpose better. As future work, we're still working on how to visualize these results to the architect. As for the missing details, also how these options would be supported. Having this plugin inside Revit, it's not enough space for us to work on visualizations as we wish to. So we're also looking for categorizing all these options. So what actually been modified, what been deleted, of course suggested for deleted, or what been really created as new things. We're gonna also go for different visualization techniques to have them as exploded views, to have walk-in options to compare different design options. If you're gonna have a wall here in this section or 2 columns or different things, so that the architect will be better provided with this information. And at the same time, giving him some sort of a bigger retro perspective, how this design process will look like. So inside his design tree, what were actually the important decision points, why these decisions have been made based on what. So it could also be seen that each of these nodes inside this decision tree could have a variant card explaining generic stuff or important stuff about this variant. If it's a decision point, so what this decision was based upon, and what actually was the important thing at that point for the architect. Thank you very much for your attention, and I'm looking forward to the questions.